Hello, this is the fourth video in my Formula Student series. Today we're going over custom symbols, footprints and 3D models in KiCad. Let's get started. The first thing I want to show is how to add a symbol for a component if you can't find it included with KiCad. So, for example, let's say that I've decided to swap my clock division circuitry up here with an SPLD, and this is what I've selected, but I've been looking for hours and I can't find it on KiCad. Then what do? Well, this one is particularly easy because on Mouser, the site where I found it, they have this little box you can click on. You can download the symbol, footprint, 3D model, everything you could need. Sometimes a site like Mouser might not have them, but if you do enough digging you can usually find something, or if not you can make your own, as I'll show later in the video. But for this SPLD we can just download it from here. All you need to do is leave all of these as they are. I wouldn't change the 3D format, especially for KiCad. Step works fine, and it includes colour, which is nice. Download CAD model, then just create an account for this. It's not an account for Mouser if you're following this exact example. It's just for this Samac Sys mini website thing that lets you download footprints. It's quite similar on other websites like DigiKey. I've already got an account, so I will just log in now. There we go, it's downloaded a zip folder which has everything we could need in it. So let's minimize that for now. Then we can open up File Explorer to find it. Just extract the contents of the zip. And then it's this folder that we're looking at, and you can see it's absolutely full of stuff. For the symbol, what we're looking for is the KiCad folder. And the next thing we're going to do is head back to KiCad. Click on this, create, delete and edit symbols, and then click File, New Library, then Project. We want a local library, not a global one. That's so that if you share the project like how I showed in the last video by zipping up the whole projects folder, then it will include this library so other people don't have to do this process. Then just find your project directory. Create a new folder in the project directory called Libraries. If you're on the race team, follow the syntax I'm using as well, so all lowercase for libraries. Then for symbols it stores them as a single file, so there's one file that stores all of the symbols within a library. The library itself, a symbol library, is one file, whereas for footprints and 3D models it's a folder containing individual files. So we want to call this symbols, all lowercase. And I just got an issue because I've already got a symbols library that I've made. That was for the 4026, obviously you won't have that problem. Then scroll down and select the new library you've just made called symbols. Then do File, Import Symbol. Go to your Downloads folder, and in the KiCad folder, there you can see the .lib. That will be the symbol that you've just downloaded for whatever device you're wanting to include in your project. Then just press Save and close that. Now we can just add it like we'd add anything else. So browse symbol libraries, scroll down to the symbols one that we've added, and there we go. Now you might be thinking this looks a bit horrible because it's not yellow. We can fix that. So if we go back to the editor, scroll down, symbols, click on the symbol we've just added, and then on the box, this is quite common that the included ones have the yellow background and imported ones don't, and they look a bit shit. So click on the box, press E for properties, then click fill with body background color, then save and close, and if you've added it you'll have to re-add it. There we go, now it matches everything else. So that's how to add the symbol. Now we want to give it a footprint, but with the majority of things where you add a custom symbol, they're usually something with a fairly standard footprint, so there'll be microcontrollers that'll be QFP or QFN or BGA or something like that. Or if you're adding a custom footprint, it might be for a connector, and connectors have fairly standard symbols. There are some things where both are true, but for example, this chip, if we have a look on Mouser, is a TSOP20 package, which is very standard, so I can just double click. Then on the footprint here, it's already got one assigned. That's assuming that we've also imported the footprint with it. but we're not going to. We're just going to go to SO and then TSOP, what was it exactly? TSOP 20. And we can see there's two different TSOP 20s with different pin pitches. So let's head over to the check the data sheet, because it doesn't say on the Mouser page. And if we scroll down to the bottom, here we go. Let's see what it says for pin pitch. 650. So let's have a look back here. We've got 0.5mm and 0.65mm. So I think we can safely assume that 650 aligns with 0.65mm. Now, you could just download the footprint from the internet for everything where you download the symbol, but then let's say I had 3 different chips that were all the same footprint. If I downloaded different ones, they all might all be slightly different, and you end up with a bit of an inconsistent board. Whereas if you use the included footprints where possible, everything will match a bit better. I would always say, if KiCad has it, use it. So now let's head to the PCB editor. We can bring in our new chip, just to check it's all fine. Let's just pop it up there. It's very small, isn't it? Then Alt-3 for the 3D viewer. There we go. KiCad also usually includes 3D models for common footprints, so that's one less step you have to do as well. Let's have a look at that. Oh, isn't it so cute? So that's how to install a custom symbol. Let's have a look at a custom 3D model now, because this USB connector is annoying me. We already have the footprint for it here. We already have the symbol for it over here. It's just the 3D model we don't have. So the first thing I would do in this case is go shopping and try and find it. Right, here's a nice one. So you might have seen me going through quite a few options there, and that's because it's a very common footprint for this USB Type B connector, but the 3D models vary quite a lot, and this one has all the right colours and things. So I'm going to do the same thing, download it. There's the zip. And now what I'm going to do is, there's no tool to do this on KiCad, so you have to just sort of do it manually. If we go to downloads, unzip the folder again, then open it up, click in here. We want 3D, and we've got STP, or step file. Now we're going to copy that. Then we're going to head over to our project folder, where we've made our libraries folder. And now we're going to make a new folder called 3D models. Then we're going to hop into there and paste our STP file. Close that. And now what we're going to do is head to the PCB viewer, double click on the footprint, and then at the top you can see 3D models. Click on that, and I'll bring it over here. We're going to do delete whatever it was trying to find before. Then we'll do add, click on the little folder, find the project directory again, 3D models, STP. There we go. And it almost always imports in some weird orientation. So thankfully they give you a mini PCB with the footprint on, so you can make sure it's on the correct side and everything like that. And the controls for moving them around are quite easy to use, normally. There you go, hopefully you can see how with enough fiddling you can get it the right way around. Then the scale is pretty much always going to be correct, but then you can move it around with the arrows. So I'd recommend using these options. So if I click this, now I'm looking at it perfectly from above, and I can shift it around with these. And it's nice to try and get it all done perfectly. I'd always use 2 different views. So right now we don't know how far off from the board it is. So if we click on this side view, that's probably the next most helpful one. Then we can get it lined up in the Z axis as well. Often the view from the bottom is a helpful one, so you can see if it's perfectly aligned with the pins, and I think I've done a pretty good job of that. So let's press OK, and now if I press Alt-3 and go back to the 3D model, look, it's got the USB connector there. It looks so much better if you've got a design, if you can get every single model there. It's just a standard step file, so if you're good with CAD you can make your own as well and import them in. I'll quickly show the process for importing a footprint. It's very similar to the one for importing a symbol. So let's say I wanted to use the footprint that I've just downloaded for this USB connector. Then what I can do is I need to head to the symbol editor, which you can either access through the PCB editor or through the KiCad project viewer thing. You can do footprint editor here. Then what we want to do is file, new library, project. Then again find the project directory. Now in the libraries folder we're going to create a footprint library, which is going to be called footprints, all lowercase, .pretty. Again, you can call it what you want, but if you're on the race team, please stick to these names. It just helps if we're combining projects or anything like that. Save. Now scroll down to footprints, select that, file, import, footprint. Then I'll head to downloads, go to the thing for the connector. Then in KiCad, KiCad_mod is a footprint file. Okay, there we go. Looks good. Save. When you save, you have to select which library you want to save it in. So just scroll down until you get to the footprints library. Save. Then we can close out of that. Head back to the schematic. Double click. Assign a footprint. Footprints. Give it that one instead. And it's basically the same. You can see if I update, I can bring it in. All it's basically done is just messed up my placement. So again, that shows if KiCad has a footprint you can use, I would usually stick with it. Connectors are probably the most common thing that needs custom footprints, and logic stuff like microcontrollers or any processy things with lots of pins, they seem to be the most common things that require custom symbols. The next thing I want to show is how to make your own footprint or symbol. So we'll start with the symbol, and what I'm going to do is get this 4024, which is absolutely hideous, and tidy it up so it looks like the others. As I said in the previous video, this 4026 I did make myself. I basically got a 4020 and just changed it a bit. So let's do something similar with the 4024. So we can enter the symbol editor, scroll down to our library we have, symbols, and then let's find a chip we want to copy. So let's just get a 4020 like I did for the 4069. So then you just do File, Save As, scroll down to find the symbols library, double click on there. I've accidentally saved it as a 4020, but you could have changed its name in that box. What I'll do is I'll save it again just so the name's right. 4024. Okay. Once you've added them to the new library, just press Save All to get rid of it being highlighted bold. Now what I'm going to do is I'm going to put this on one side of my screen, and I'm going to put the known good 4024 on this side, and we're going to try and make this look the same. The first thing I'm going to do is delete this, because this is a link to the datasheet and it's not a 4020 anymore, so that's not very helpful. What we're going to do is go through each pin one at a time, and we'll start by just changing the numbers because these chips are very similar. What you can do is go through each pin, double click, pin name. I want it to be called the same as the others, so let's just have a quick check. VDD, yeah, so I can leave that. VDD pin number, the pin number we want is 14. So basically the pin number here is which pin it then relates to on the footprint, so we can't change those. We've got to keep those the same as the ugly 4024. It is a power input. We're going to keep the graphic style the same, and we're not going to move it around. That all looks okay. Then next, what we're going to do, I'm going to delete all of the outputs higher than Q6. So let's do that. Select the pins, delete. Now I'm going to go through these, making the pins the same as this. I've also just noticed that 1 and 2 are missing, so I'm going to copy and paste 3 there and there. And now I'm going to do the same thing as I just did before, but with these. There we go. I would normally recommend editing a footprint over making a new one from scratch, just because why not? You can see how easy it is. Now the power input is pin 7, or ground. And then I'm going to shrink this box now, so you can just click on the box, then get a corner and drag it in. You'll probably leave behind a pin or two. You can bring them up manually. Next we've got the clock and the reset inputs, which I'm going to leave the same, except the pin numbers. So we've got pin 1 and pin 2. If you're editing a chip that doesn't have a clock input and you want that little triangle to show it's the clock, that's one of the options you can have on the graphics style. So clock, there we go. Or you can make it an inverted input. Inverted clock is an option. So you can really just play around and you can usually get what you want from it. Then another problem we had in the last video was that this footprint that we're using for the 4024 has some unassigned pins. So what I'm going to do is I'm going to have a look online, see what those pins are meant to be, and see if we can come up with something to do with them. There we go. So it was pins 8, 10 and 13 which aren't connected. So what we're going to do with those 3 pins is make some hidden not connected pins. So let's copy this one and double click. We're going to call it NC for not connected. Then pin number 8 is the first one. Unconnected, electrical type. We'll leave the rest of it. And then visible we're going to uncheck, which basically means it appears like this in the symbol editor, and then when you import it into your schematic, those pins should just not show up. Then we want 2 more of them, and the numbers were 10 and 13. Then I'm just going to drag this back up to where it was before, and that should be our 4024 without any of the electrical rules check issues that we had before. Save that. Then let's try importing it into here. So symbols 4024 is the one we want. Click on that. There we go. See, the hidden pins aren't there, but KiCad knows that those are supposed to be unconnected. So it's basically put no connection flags on them for us. You can see that with the little X's actually. So let's swap our 4024 for the nice new one. What I just did there was take a picture of it, which I'd always recommend if you're doing something like this. Just take a picture or a snip on the computer, just something to look at. There we go, it's not my neatest work, but it should work. I'll assign it the footprint as well. There, isn't that so much nicer? And that's our first step to making a nice, neat schematic, which is exactly what we're going to be doing in the next episode. All that's left for this one is to show how to make a custom footprint, which is a very similar process. Find something that's close to what you want and adapt it. So let's go back to the footprint editor. And the example I'm going to use is just modifying the USB connector that we have with bigger pads to make it a bit stronger. Let's get this one, then again, File, Save As. We want to save it in the new footprints library, and let's call it Fat Pads. And then basically every little part of the footprint you can change by just double clicking. So I can double click on this, and this is a ring of copper that you're going to mount onto. It's the pad, and you can see we've got the size of the hole in the middle and the size of the actual pad. So if I change this to 5, it gives me a little preview down there. That would be a lot more secure as a way of mounting. So let's just change them both. Then press save, and you assign the footprint the same way. Go to this footprints folder, select it from there. It's not very often that you need to make your own footprint. Usually you can find it somewhere online. If not, what I would recommend doing is finding the page of the datasheet that talks about it. So if I get the datasheet up for this connector, for connectors, basically the only thing on the datasheet is the dimensions. Then we can have a look here, and it tells you you've got loads of dimensions here. The PC board layout's probably the most useful one. So it says put a hole here, this far apart, that kind of thing. So again, you could probably find a similar footprint and then drag the holes so that they're exactly 12.04 millimeters apart, put any new holes in by copy and pasting, that kind of thing. You can start completely from scratch, but usually it's easier to just get something that's close, copy and paste a few things, delete things, change things. And that's it for this video. Hopefully it's a bit shorter than the last one. As I've already mentioned, in the next video I'll be covering tidying up the schematic, which is always quite a fun thing to do, is make the schematic just really nice and neat. But until then, I hope you enjoy your birthday. Goodbye.